Hello, I'm your lesson teacher for this presentation, and I am Charity.
Welcome, everyone. Today, we're going to explore the fascinating world of mixtures. Can anyone tell me what a mixture is? That's right. A mixture is a combination of two or more substances present in varied proportion that are physically combined. The substances in mixture retain their individual chemical properties that aren't chemically bonded. The gloves, face masks, and disinfectant solution are some of the examples of mixtures because they were made using the combination of different materials. Types of mixture.
There are two types of mixture, homogeneous and heterogeneous.
1. Homogeneous mixture, which contains substances that are evenly mixed and is uniform throughout in terms of physical appearance. I will show you a demonstration of homogeneous mixture. Food coloring mix in a cup of water. Observe how the coloring is evenly distributed throughout the mixture. Let's have another homogeneous mixture using salt and water. Observe how the salt dissolves into the water. Homogeneous mixtures have uniform composition where the substances are evenly mixed. They are also called solution. In its component, the substance that dissolves or seems to disappear is called a solute, while the one that dissolves is the solvent. Most of the time, the formation of this kind of mixture is associated with process of dissolving. We say soluble if the solid solute completely dissolved in the liquid, solvent, and insoluble if it is not. While if the components are both liquid, the term miscible or immiscible is used.
Salt dissolves in water. Salt is the solute, and water is the solvent. This property of solutes is called solubility. It is measured in the amount of solute that can dissolve in a fixed amount of solvent. There are three types of homogeneous mixtures. These are: Point 1. Solid homogeneous mixtures. Point 2. Liquid homogeneous mixtures. Point 3. Gaseous homogeneous mixtures. And the other one is 2. Heterogeneous mixture, which contains component substances that are usually easy to distinguish. Example: we mix oil into the water. Observe what happened to the oil being poured to the water. You can clearly see the oil floating on top of the water. That means the mixture isn't uniform, making it heterogeneous. An oil and water mixture is called an emulsion. Emulsions are mixtures of two or more liquids that normally don't mix, like oil and water. Another example of heterogeneous mixture is sand and water. Observe how the sand settles down to the bottom of the water. Separating a homogeneous mixture. Presenter. Lastly, we will discuss the techniques on how to separate heterogeneous mixtures. We will separate the mixture sand and water that we have mixed earlier. By using filter towel, you observe that the sand remains into the filter and the water passed from the filter towel. Separating mixtures involves physically isolating different components without changing their chemical composition. Here are common methods. Filtration separates solids from liquids using any filters. E.g., think of straining pasta. Evaporation removes a liquid from a mixture by turning it into a gas. E.g., boiling water to remove salt. Distillation separates liquids with different boiling points. E.g., purified water. Magnetism separates magnetic materials from non-magnetic ones. E.g., using magnet to pick up iron. Filings from sand. Decantation, carefully pouring a liquid off a solid, leaving the solid behind. E.g., pouring water off rice. Properties of mixtures. No chemical bond, the components of mixture are not chemically bonded, meaning they retain their original chemical identities. Variable composition, the ratio of components in a mixture can vary. E.g., a mixture of salt and water. Can have different concentration of salt. Retention of original properties, the physical and chemical properties of the components of a mixture are generally preserved. E.g., a mixture of sand and water will still have the same properties as sand and water individually. Separable by physical means, mixtures can be separated into their individual components using physical methods like filtration, distillation, evaporation, or magnetism. What did you learn from these demonstrations? That's right. Mixtures can be separated into their components, and their properties depend on the substances involved. Thank you for joining me on this journey into the world of mixtures. Remember, mixtures are all around us, and understanding their properties is essential for various fields like science, engineering, and more. See you on next topic.
Bye. Bye.